This is the second video for section 2.8. So if you would go past the function operations, we're going to get into composition. Compositions of functions and domain. All right, so the first thing I want you to notice is that we have this F, and it looks like an O, but it's not. We read that F of G of X. I personally like the second way of writing it better. This is the way that you're going to see it in your work, in my lab. But this is the better way to write it. And I'm even going to take that a step further and say that my personal favorite way to write it is similar, but I like using brackets so that I can see the F of G of X. So that's personal. That's what I will be doing. But either one of these two is the best way to rewrite what you see in my lab. All that we're talking about here is following the order of operations where I work with the group and then I go to the next group and I work with that and I keep working my way out. So that's really all that we're talking about here. All right, so we're going to take these two functions, f and g, and we're going to find f of g of -2. First thing is, let's go and let's rewrite it in this particular method. So again, I like to use those brackets for that. And then what we do is we follow the order of operations. Order of op says, hey, you got to work the group first. So let's work g of -2 first. Let's go find that first. So you'll notice that when I write mine down, I kept the F here because I'm not working with it yet. It's just following along because I need to remember to work with it. And then you'll notice that I took my G function and I plugged a -2 in. So you have a 4 on top, -2 goes in for the X, and then -1 gets copied. So that's the line that you see. Now I want to clean this up before I do anything. And so you'll notice that I have a -3 on the bottom. So now what I'm going to do is now I'm going to go to the F function and find F of -4/3. So we're going up to the F function, and for each X, we're going to write down or substitute -4/3. So you have a 2 times X, but instead of X, we're going to write down -4/3 minus 1. We know how to multiply fractions. Remember, this is actually a 2 over 1. So that's going to give you an 8/3 with a negative. Notice that I'm working on getting a common denominator here. So instead of writing -1, I wrote -3/3 so that I could get the common denominator. -8/3 and -3/3 gives me -11/3. Let's do another one of those. Let's find same two functions, only let's reverse the order and use a different number. So we're going to find g of f of 5. So once again, it's better to write it in a way that makes more sense. It shows me the order of operations when I work this way. So this time we're going to start with the f function, and we're going to plug 5 into all of the x's over on that f function that was in the instructions. So notice that I kept the g there. I haven't messed with it. It's just tagging along until I'm ready to work with it. But on the inside, I plugged my 5 into the f function. Clean that up. You're going to get a 10 minus 1, which is a 9. Now I'm ready to go to the g function and plug the 9 into the g function. So 4 over 9 minus 1 is 4 over 8. And of course, we always reduce our fractions. So this will be 1/2. That's composition, where really what I'm doing is I'm not taking a number and plugging it in. I'm taking a whole function and plugging it into another function.